Right now, thousands of internet satellites are on a one-way trip to their doom, and as they vaporize, they're seasoning our atmosphere with a compound that eats the ozone layer. Look up at the night sky, and you might think you are staring into the infinite, peaceful majesty of the universe. But in reality, you are looking through a crowded, chaotic highway of human-made metal. In the last 6 months alone, SpaceX has deliberately vaporized 260 Starlink satellites in Earth's atmosphere. This is not an accident. It is the planned life cycle of modern megaconstellations, designed to burn up at end of life to prevent orbital debris. But as these 2,700-pound orbital data centers turn into shooting stars, they are systematically seasoning our upper atmosphere with a highly controversial chemical compound.
Unfortunately, what starts as a convenient way to stream high-definition videos in the middle of a desert ends up as a massive, unintended geoengineering experiment. We wanted to connect the world, but in doing so, we may have built a giant global engine for ozone destruction in the stratosphere. To understand why these satellites must burn, we have to look at the physics of low Earth orbit, or LEO. Contrary to popular belief, LEO is not a perfect vacuum.
At altitudes between 300 and 500 kilometers, a trace amount of atmospheric gas remains. A satellite orbiting here travels at a velocity of v, approximately 7.8 kilometers per hour to maintain orbit, but the thin air exerts a continuous drag force. Unlike the stable, eternal co-orbital resonance of our quasimoons we explored previously, these human-made satellites are locked in a slow, relentless spiral of orbital decay. Eventually, they fall. When a satellite drops into the denser layers of the thermosphere at 80 kilometers altitude, its massive kinetic energy must go somewhere. The air molecules ahead cannot compress fast enough, creating a massive ram pressure boundary layer. Temperatures instantly skyrocket to over 1,500 degrees Celsius, literally shredding the alloy structure and vaporizing the spacecraft into microscopic dust. It's a beautifully violent purification process. Or at least it would be, if we weren't planning to launch 42,000 more of them. Tragically, this represents a scale of atmospheric ablation that the Earth has never experienced before. It is the ultimate British compromise, solving the space junk problem by simply sweeping it under the stratospheric rug and hoping no one notices. But the scariest part isn't just the chemistry. It's that the people in charge of regulating this say it technically isn't even happening. We're trading a hole in the sky for a signal in the desert. Here's exactly how that trade works. Let us look at the raw chemistry of this atmospheric crematorium. As the aluminum vaporizes in the presence of atmospheric oxygen, it undergoes a rapid oxidation reaction, forming nanoparticles of aluminum oxide, or Al2O3. Unlike volcanic ash or industrial pollution, which falls back to Earth in a matter of weeks, these light Al2O3 nanoparticles are deposited directly into the upper atmosphere. Gravity eventually drifts them down into the stratosphere over several years, creating a permanent, accumulating layer of industrial dust. And in the stratosphere, these particles act as active catalytic surfaces for chlorine activation. In the freezing polar stratospheric clouds, inactive chlorine reservoirs like hydrogen chloride, HCl, and chlorine nitrate, ClONON2, react on the surface of the aluminium oxide particles. HCl plus ClONON2, X arrow Al2O3, Cl2 plus HNO3. If you're getting flashbacks to high school chemistry, don't worry, the atmosphere is failing the test too. The resulting molecular chlorine, Cl2, is then split by incoming solar ultraviolet radiation, photolysis, Cl2 plus Hν to 2Cl. This releases chlorine atoms that act like microscopic chainsaws, cutting through the ozone layer over and over again. Cl plus O3 to ClO plus O2. ClO plus O to Cl plus O2. Notice that the chlorine radical is completely regenerated at the end of the cycle, ready to destroy another 10,000 ozone molecules. By vaporizing tons of aluminum every day, we are systematically building a high-altitude chemical reactor that eats our planet's radiation shield. Yet, the Federal Communications Commission is currently attempting to exempt satellite launches from environmental impact reviews, claiming space activities are extraterritorial. It is an absurd and ironic legal loophole. If the damage occurs at 80 kilometers altitude, it apparently doesn't count. One can only assume the regulatory agencies believe the atmosphere is someone else's problem, perhaps conspiring to keep us all looking at our screens instead of the sky. We are witnessing a strange technological irony. We have built an incredibly sophisticated network to beam high-speed internet to every corner of the globe, only to slowly dismantle the very atmosphere that allows us to survive here. This is the ultimate paradox of the information age. We are willing to trade the physical integrity of our biosphere for the convenience of instant global digital access. We want to be connected to everything, yet we remain tragically disconnected from the consequences of our own technology. As the night sky fills with the burning embers of our digital ambitions, we must ask, are we willing to trade our planet's primary radiation shield for faster cat videos? Should we ban satellite re-entry ablation, or is global digital connectivity worth the cost to our stratosphere? Share your thoughts in the comments below. Stay silly.